Okay, today we will be graphing in slope-intercept form. Our objective is I can graph an equation in slope-intercept form. So here's what slope-intercept form looks like. Y equals mx plus b. So we've been used to y equals mx when we've been talking about direct variation. And I want to remind you, we've been starting all of our graphs at 0, 0 when we've been plotting them. And then we would plot our slope. Well, now we have this plus b at the end, which stands for our y-intercept. So if we have an equation, y equals 2x minus 3, our number next to our x is our slope. That is our m, and we already know that m stands for slope. And then our number at the end here, sometimes it's at the end, I should say, it is our constant that is not with a variable, is our y-intercept. In that case, it would be -3. So the difference between from when we were doing direct variation versus slope-intercept form is adding on this y-intercept part. So number 1 says write an equation in slope-intercept form for the line with a slope of 2/3 and a y-intercept of -2. Then graph the equation. So our slope-intercept form is y equals mx plus b. And again, our m stands for slope and our b is our y-intercept. So if we're writing this equation, that would be y equals, our slope is 2/3 x, and then plus our -2, but we know that we never leave two signs in a row like that, so I'm going to simplify that to y equals 2/3x minus 2. And all that's saying is our y-intercept is -2, and that's where we're going to start. So you're always going to start at your y-intercept. Just like before, we always started at 0, so this time we're going to start at our y-intercept. And so we know that our y-intercept is always on our y-axis, so that would be at -2. So I'm going to start a point there, and that's technically 0, -2. And then I'm going to plot my slope. And so from that point, so instead of from 0, 0 like we were used to, we're going to go from our y-intercept point. And so I will rise over run. So my slope is 2/3, so I will go up 2 and then over 1, 2, 3 to plot my next point. And I can repeat the pattern, up 2, over 1, 2, 3. And I can go down 2 and left 3 to make a third point this way. And even continue 1, 2, 1, 2, 3. So that I can draw a nice straight line. Excuse my crooked line. Example 2, write an equation in slope-intercept form of the line with a slope of 5 and a y-intercept of 1. So again, I'm going to bring down our y equals mx plus b. And so we are going to plug in our slope and our y-intercept. So we have y equals, our slope is 5, x plus our y-intercept is 1. And so we're going to graph this, and we're going to always start at our y-intercept. So again, instead of 0, 0, we're going to start here at +1, which is the same thing as 0, 1. And we're going to put a point there. And then we plot our slope. So we know that if it's a whole number, we always put it over 1. And so from our y-intercept, we're going to go up 5, 1, 2, 3, 4, 5, and then over 1 to make a point. And then we can do the opposite and go down 1, 2, 3, 4, 5, and over 1. Again, you're counting your slope from your y-intercept before you graph your line. Number 3, write an equation in slope-intercept form of the line with a slope of 0 and a y-intercept of -3. Then graph the equation. So I do want to remind you what we talked about. If a slope is 0, what that line would look like, what would happen to our little man and how he would be walking. And so thinking about y equals mx plus b, we're going to still plug in our slope and plug in our y-intercept. So we have y equals, our slope is 0, x, and our intercept is -3, or in other words, plus -3. So we have y equals, so 0x means it just cancels out. So I'm just going to leave that alone. And then we never leave plus -3, of course, so we really just have -3. Y equals -3. So this is still our y-intercept, and so we're going to still start at a -3 on the y-axis. And then our slope is 0. So that means we can't go up at all. It just means it is a straight line at -3. So all of these points are on this line. And so anytime you have a slope of 0, it's just a straight across line at your y-axis. At your y-intercept. And last example, so we're going to graph 3x plus 2y equals 4. So we've taught when it looks like this in standard form that you use your intercepts. Well, if you do that with this problem, you're going to get a weird intercept that's a fraction, so it might be difficult to graph. So instead, you can use your solving for y skills to put it in slope-intercept form and then graph. So we want it in the form of y equals mx plus b. And so basically, you solve for y. So we know that if we have this equation, I'm going to bring it down, we would first want to move the 3x term over, so it's positive, so we're going to subtract 3x from this side. So we bring down our 2y equals, and we have -3x and that positive 4 that we didn't do anything with. And then, of course, to get rid of this 2, since it's being multiplied by the y, we would divide everything by 2, divide by 2, divide by 2. So our new equation would be y equals -3 over 2 x plus 2, because 4 divided by 2 is 2. So now that we have this in our y equals mx plus b form, we know that this number in front is our m, or our slope, and this number at the end is our y-intercept, or our b. So we're going to, of course, start with our b. So at +2 on our y-axis, we're going to put a point there. And then from there, plot our point, our slope. So we're going to, it's a negative slope, so little man will be falling down. So we're going to go down 3, 1, 2, from our y-intercept, 1, 2, 3, and go over 2. And again, just continue the pattern, 1, 2, 3, over 2. And you can, of course, go the opposite way, up 1, 2, 3, over 2. And draw a nice straight line with your ID. All right, here's the you try problem. So you're going to start by writing the equation and then graphing the line and bringing that to class.